Powerful collaborations, cutting-edge science, and curious minds coming together for a glimpse of the future. Stay tuned as we look at the latest updates on some of the most promising technology projects. Hello and welcome. I'm your host, Peter Ballant from Technicon. Today we will look at the EPIC project once again. EPIC is focusing on overhauling today's error correction algorithms for the next generation of superfast wireless network speeds. In simple terms, EPIC is ensuring that you get the most error-free data communication experience possible. In this episode, we speak with Onur Sahin. He's an engineer and manager from InterDigital Communications in London. InterDigital is an EPIC partner contributing years of experience in digital communications. They research the development of new forward error correction technologies. Welcome to our podcast, Onur.
Thank you, Peter.
EPIC is all about making sure that everyday electronic communications equipment will continue to function at future network speeds that are dramatically increased. Can you give us an example of what kinds of devices these might be?
Oh, absolutely. I think when we say everyday electronic equipment, so wanting to distinguish, EPIC is positioning itself for future technologies, and that also means future electronic equipment. So there are some examples we can give today, like mobile phones or gaming equipment, so on and so forth. But the real impact of EPIC will be for future technologies, products that we are not even sure of at the moment. So that's the beauty of the project. We have some guesses, very wild guesses, like looking at a crystal ball in a way. So one of them, primary one that we foresee, which might have highest potential, is AR/VR goggles. So we see the initial releases, products everywhere, but they're not mainstream. So in order them to be mainstream, you need very high data rates to support these devices. And EPIC and the technology behind EPIC will be crucial, we hope, or we think, behind these products, AR/VR goggles. The other use cases or products will be 360 video monitors. And those monitors could be hologram based, or it could be physical. Again, we do not know at the moment. But in order to support very realistic, haptic, interactive 360 video, ultra high definition, again, we will have to rely on very high network speeds, and there are core technologies that will enable this, and EPIC is one of those technologies. Some other examples we have thought are in the network, a real infrastructure. So every base station is connected to other cloud units through fiber. In the future, we anticipate that some of these network equipment, as we denote, they will be connected in wireless fashion. So we will need to come up with wireless technologies to make the network seamlessly connected. So those are pretty much our best guesses, where EPIC could be relevant for future electronic equipment.
Okay, and let's just back up one moment. You mentioned AR/VR goggles. For the people that don't know what that is, can you explain?
Oh, of course. So that is augmented reality, virtual reality goggles. So those are the goggles. For instance, Facebook has one. Oculus, for instance. So the goggles, you put the goggles, and in augmented reality, there is a virtual layer on top of the physical layer that you observe in the real world. Or virtual reality takes you to a virtual world, literally, in a 3D environment, and you could interact with the virtual objects around you, and you could also communicate with others, which are far away, and as if you're sitting next to each other. So those are literally the physical goggles that anyone can use, or anyone will use, we anticipate in the future, which will probably replace the mobile phones as we use today.
Okay. And the reason you bring up the AR VR goggles is because they're so data intensive. Is that it?
That's absolutely the case. They're extremely data intensive. And the main reason is that these things, the beauty of these products or technologies is that they are trying to be at least as realistic as possible. So in order to bring this reality, you have to transport the environment, everything you want to see when you put the goggles on, right next to that equipment. And that is huge bandwidth, huge data that you need to transport in real time from wherever this data is coming from, right onto goggle that you will be using. So that those are the technologies, products that will consume substantial amount of bandwidth throughput in the future.
Okay. And the way that you're doing this in Epic is you're focusing on forward error correction, which maybe you can give an idea of what that means to our listeners who may not be familiar. I mean, we all know this, we talk about it all the time, but I don't think the average person has an idea about the error correction that has to go on in normal wireless communication, for example.
No, absolutely. So, first of all, forward error correction, FEC, it is one of the main components of any wireless systems. And the reason is kind of obvious. So, when you transmit a signal over a wireless medium, there is all different sources that impact or that degrade the wireless signal. So, it's noise, for instance, white noise. There is white noise in the universe or in life that we observe. So when you transmit a signal, they are degraded by noise, by the device imperfections, so on and so forth. So there is never such thing that you transmit a wireless signal and you receive it perfectly, because we're not living in perfect environment. There are so many imperfections, so on and so forth. So in order to recover what was degraded or what was in error, we use forward error correction. So what it is that it is an algorithmic block. It's actually a hardware unit. If we open up your phone, if we disaggregate the phone in different components, you will see a chip, a very tiny chip, that is actually doing this. So it takes the wireless signals that you want to transmit. It runs some very smart algorithms on top of the signal, and then after that it goes through other modules in the electronic equipment and transmitted. That's the transmitter. And at the receiver receives these wireless signals. Knowing that smart algorithms, it also performs other algorithms to recover the signals that were in error. So that is the principle of forward error correction. And due to dynamicity of wireless environments and all, it is a core enabler in order to transmit and receive data stream without error or with as minimal error as possible.
And if we didn't have forward error correction, it seems like the receiver side would say, I didn't get that, send it again. I didn't get it, send it again. And the message would have to be sent over and over and over. We kind of alleviate that with forward error correction, right?
That's true. And actually, even though receiver says, send me back, there will be cases that it will never be possible to transmit any data, particularly when we increase the data rates. To put it boldly, so if we did not have forward error correction, we would not have 3G, we would not have 4G, we would not have 5G. So these blocks are making it possible to transmit any packet over wireless or even wired medium. So because there are errors in wired communications as well, even in fiber, in Ethernet cables, so on and so forth.
And when I look on your webpage, all of your efforts seem to be focused on the beyond 5G speeds. How would you explain that beyond 5G to someone who maybe has a limited knowledge of communication speeds, network speeds?
Absolutely. So so if we first of all consider 5G, which is about to be rolled out, and in 2 years, 3 years time, we expect that to be a mainstream technology. We are talking about peak throughputs reported or marketed peak throughputs in the order of 20 gigabit per second. So which means that you will be able to download an HD movie, 2-hour movie within 4 seconds on your mobile phone, on your laptop. Yeah.
Incredible.
Yeah, that is marketed speed. So what we are targeting is 50 times higher speeds than what 5G markets. It's 1 terabit per second.
Uh-huh.
So what does that mean? Again, in terms of use cases, there are no use cases actually in need of those data rates or those bandwidths. But if you look at any prediction or any trajectory, how these data rates consumptions have been happening in the last 30 years, there is a very steady trend. So if you will remember in 3G times 10 years ago, if you look at how much data you were using with your mobile operator, I would argue that it would be less than, let's say, 100 megabytes. Then came 4G. Right. Now you're using gigabytes of data, right? Your packets, your data cap. In 5G, it will be in the order of hundreds of gigabytes, maybe terabytes. So when we go above or beyond 5G, and beyond 5G, the data requirement per person will be easily higher orders of terabit per second. So those are the data rates we are aiming. And again, I think it's a very critical point. Epic is a technology push project. It's not a market pull. So we push a technology, pretty much laying the ground and saying that, look, we built the infrastructure, we built the enablers, the creatives, use case providers, application providers, you have the enablers, come up with the next Facebook, come up with next AR, VR goggles, come up with next Apple product. So it's a core technology push project.
Okay. Yeah, this is interesting. I had not heard it referred to in that way before. And so you have the data to show that data speeds will increase, and you are building for that time, which is kind of interesting that you don't know exactly what you're building for, but you have a pretty good idea.
Mm-hmm. Yeah, if you look at any technology cycle, the 3G technologies were built without knowing that there would be iPhone. 4G technologies were built without knowing that we would have WhatsApp everywhere. No one knew about WhatsApp. No one knew about iPhone when 3G was built. The cycle is about 5-10 years before the products were released. So these are the technology innovation actually moves in a more technology push, or R&D, I should correct myself, the R&D of technology. It's more technology push fashion, not market pull, or we need this product, come up with a technology. That also happens, but majority of the R&D happens in terms of pushing the envelope in scientific state of the art. And then comes the products on top. So again, if you look at 3G R&D, that was significantly before when first iPhone 1 was released. And then if you look at 4G, everything IP and everything connected in a seamless fashion and all. Then came WhatsApps, then came Facebooks. So now we are in 5G. We are in beyond 5G research era. We have some guesses about what the applications, services will be. But what we are really doing is we are pushing the envelope in science, in engineering, regarding the state of the art, regarding the enablers.
Okay, so there's a lot of work being done in Epic. What is your particular role in this project?
You mean as InterDigital? Myself or...
Let's talk about you first. What do you do for Epic? And then we could maybe talk about your company, InterDigital, and what do they bring to the table as well.
Sure. So myself, I am the main representative of the company at Epic Project. And I focus on the polar code research and development in the project. Myself and my team at InterDigital, we have been doing research in developing new polar code technologies. So from technical perspective, that is my involvement in the project. And the other hat I carry in the project is that I am the dissemination lead and standardization lead of Epic Project. So what it means is that this amazing technology is created, developed by partners. I take them and I disseminate them as much as possible in different forums and standardization meetings. So this is a collaborative project. So even though individual partners create their own technologies, we have a lot of collaborations. And it's my responsibility in this project to disseminate all these novel new technologies in the most appropriate venues and forums. So these two are my key roles in the company: technical role to help develop new polar codes, dissemination, standardization role to take the technologies developed in the project and disseminate it as broadly, as impactful as possible.
Okay, and with your dissemination duties, does that include publications too? So if you have discoveries that you publish, do you share these things right away?
Absolutely. So we do, absolutely. Every partner individually publishes their work, but we also have joint publications. So as partners together, we publish co-authored or joint scientific publications. We absolutely do that. And once we invent technology, depending on, again, the strategy of every partner, some partners or most partners would like to protect their ideas, which means they go through some patenting procedure, patent applications. After those applications are cleared, the next step, immediate step for us, which is very critical, is to publicize what we have invented, what we have developed in the project. So the answer is absolutely yes. That is a very critical part of the overall dissemination effort in the project.
Okay. And Onur, what about tangibles or something or demonstrators? In many projects, the end result is having a demonstrator. Is there anything like that in this case with Epic?
We definitely do. Actually, kind of a sad story. We wanted to demo our technologies at Mobile World Congress in February. As you know, that is the biggest industry forum and exhibition venue in the world. So each year it's in Barcelona. 500,000 people attend MWC each year. Yeah, it's one of the largest events in the world. And we have prepared everything, all our demos and all. And literally a week or 2 weeks before, the event got canceled because of obvious reasons, COVID reason.
Incredible.
Yeah. And the demos we have is a hardware platform, size of a 20 centimeter to 20 centimeter hardware board, which we call FPGA, where we implement our technologies, these algorithms, in software and architecture build up, hardware architecture on this FPGA, and we demonstrate in real time what data rates, throughputs we obtain during the experimentation or during the exhibition. So in this demo, in this hardware platforms, we were able to demonstrate up to 200 gigabit per second in real time. So if we had the exhibition, a person would come, press the button, and this fancy, highly complex algorithms would run on this hardware platform. And in a monitor, you would see in real time what the throughputs were. And we had a very nice chart showing 5G speeds, and the results we obtain are 10 to 20 times higher than 5G's peak data rates, throughputs. So we have this demo. We didn't have a chance to demonstrate, but we're hoping that there will be other opportunities to show.
Yeah, I was going to ask, will you have that opportunity? I mean, Epic is done. The project itself is done, I think, at the end of this year. So, is it? Can you still show this product?
Yeah, it's
along
actually
the line somewhere.
Yeah. The project will be done actually not even end of the year. It will be done by October. And to our knowledge, all events in the foreseeable future are canceled. we are hoping that even the project is over, of course, that needs discussions among the partners to have this demonstrations presented at some of the important venues. So the answer is we are very hopeful, but at the moment, unfortunately, we don't even know a particular event that we could bring these demos for exhibition.
Yeah, it's a real shame. You put in all that work and then you can't do anything with it. So I hope that at some point you'll be able to demonstrate this in a meaningful way.
That's very
and
true.
yeah,
Absolutely.
and gain some traction with your work and your research.
Yeah, exactly.
And I want to ask you again personally, at the end of Epic, what does success look like? When will you be happy?
Yeah, I don't think that ever comes, in a research project. There is
Okay,
no such thing
fair
that,
enough.
that's it. But I think we're already happy because when we started the project, we had very precise requirements to achieve. We said, okay, we will, and we had no idea if we would be successful or not, but that's how research is done, right? So we said, okay, we want to achieve this 1 terabit per second bandwidth throughputs, which is 50 times higher than 5G. And I'm very happy to say that it was a success. So we have a real-time demonstration. We have all the technologies, implementations, and any demonstration that we are able to prove that it's possible. So based on our algorithms, technologies developed in the project over more than 2 years. So that's excellent. So the real achievement for us would be that the results or the technology we have developed will receive traction in the industry, and they will be at least part of discussions for beyond 5G era. Meaning that, okay, we need these technology for their correction. Which technology are we going to use? If Epic can play a role there, saying, okay, we have developed this, have a look, and if it is accepted or considered or discussed, that would be a real happy moment, I'm pretty sure, for all of us in the Epic project.
Okay, and give us an idea of, I know you can't say exactly when, but something like this to become used in mainstream society, how long does this generally take? Could this be in the next 2 years, for example?
No, 2 years is a very short time in R&D,
Okay.
R&D being in product. It's extremely short time. So that timeline is rather clear. The R&D timeline is clear. So 5G research will carry on another 5 years. That will be the 5G core research is completed as of this month, actually, last month. But upcoming 5 years, we anticipate will be enhancement of 5G technologies. And after that, 2025, we expect 6G era discussions to kick off. So requirements, fundamental technologies, so on and so forth. So within that 5 to 10 year window, we expect that these technologies will be considered or investigated in great depth. And the first products, in my humble opinion, will be in market by 2030. So I I have a I have an opinion or estimate guesstimate of them being in mainstream by 2030.
Mm-hmm. Okay. Well, you're almost at the end of the project, and it sounds like you're happy with the way things have come along thus far. So I could wish you much luck for the rest of the project and whatever it is, wherever this technology happens to take you. And thanks for doing the project, first of all, for advancing science and technology. And also thanks for taking a little bit of time to try to explain to someone who might be out of the loop on the technology side a little bit about what you're doing. I think it's important that people understand what's really behind the technology that they use. So thank you.
Thank you, Peter. I hope I gave a bit of a glimpse on what we have been doing. And I definitely agree with you. I think the key thing is explaining in plain terms what all these core or advanced technology projects are about. And it's possible. And hopefully we will see traction, or Epic will be one of the core technology components of 6G And we will remember these days as real, like the intense, long research days as very happy and prideful moments.
Yeah, that would be quite a payoff for all of you when this technology is finally used to its fullest. Yeah,
exactly.
All right. Thanks for all the information. We'll talk soon.
Thank you very much.
For more information about the EPIC project, check out their website, epic-h2020.eu. This podcast has been brought to you by Technicon. The EPIC project has received funding from the European Union's H2020 Research and Innovation Program under Grant Agreement number 760150.